We are talking about nature of the roots of quadratic equations. All right. We want to know the nature of the roots of quadratic equations. All right. Already we know that any quadratic function or quadratic equation have what? Two roots, right? One can be they can be different. They can be the same, or maybe they can be complex numbers. Yeah. So we have there is an expression that we use that normally determines the nature of the root, and that expression is called determinant. So that this is called determinant. As we know, for you to find the root of any quadratic expression or equation, there is a standard formula, which is this: x equals plus or minus, minus b plus or minus square root of what? B squared minus 4ac all over 2e. This is it. But guess what? We need, you see that this square root, whatever that is in the square root there, the radical, yeah, actually tells us what the nature of the roots are. Okay, so because of that, you see that we normally cannot have a negative number here, right? Yes. So if that happens, there will be a complex system, right? You get complex roots. So in this case, we want to focus on this. We want to focus on the expression under the roots. That this expression, which is b squared minus 4ac. It tells us whether the quadratic equation is what? Has two equal roots, or no root, or complex root, or two distinct roots. When we say distinct, distinct simply means different, right? For example, as you can see, this duster and this marker are different, therefore they are distinct, right? So now let's see. What happens is that if we have b squared minus 4ac is equal to 0, it means we have two roots that are the same, like 2 and 2, 3 and 3, 4 and 4, or minus 1 and minus 1. That means x can have two values that are the same. All right? So we are going to look at the shape of the quadratic or parabola as well. So when this happens, if you have the x axis here, the quadratic will either touch it this way, or it will touch this way. It will only touch the x-axis at one point, only one point. Therefore, the x-axis will be a tangent. It will be a tangent to the curve, okay, the quadratic curve. All right? Now, that is it. Now, what if we have, so these are the two equations, two conditions we have for the curve. So here is when, we have a standard form of quadratic equation. Okay, let's write it. So we have ax squared plus bx plus c equals 0. For this case, when a is greater than 0. For this case, when a is less than 0. That means when a is negative in this case, here when a is positive. Okay? Now let's have another one. What if we have a situation where the determinant, which is b squared minus 4ac, is greater than 0? Yes? What if this one is greater than 0? What can we say about the roots? So in this case, we will have two roots that are different or distinct, right? So in this case, we will have a curve that x-axis like this, and the curve will cut it at two distinct points. That is where the name distinct comes from. Because the curve is going to cut the x-axis at two different points, and therefore those two different points will have two different numbers. That is why the word distinct comes from, right? So we have here a value here and a value here. These are the two roots that are different, distinct. Now, in this case, it can be this way, or it can as well be this way. Yeah? Oh, I think you don't see that one. Right. Okay, I think I need to go up here. So it can be this way, or it can we can have our x-axis and the graph can be this way. So these are the two distinct points. Okay. Now, what's for this situation? Here, it's the same here. Here is when the quadratic, the coefficient of x squared, is greater than what? 0. Here is when the coefficient of x squared, which is a, is less than 0. Right? So that is it. So I think I can come and do the next situation here, right? Yeah, let me, yeah. So let's look at this. What if we have a determinant, let's say b squared minus 4ac is less than 0. If it is less than 0, it means that, look at this, do you know this is a determinant? So we have x equals what? Minus b plus or minus all squared what? B squared minus 4ac over 2. If this is less than 0, it means that the answer or whatever, the quantity we are going to have under the root or the radical is going to be negative. And we know that if you take a standard calculator, you punch square root of a negative number, it will tell you error or math error. Because we cannot take square root of a negative numbers, but we can find solution to this, and that is under complex number system. Okay, yes. So your calculator has that function. You can change it and you will get answer. That's complex numbers. So whenever this happens where the discriminant is less than 0, that means the expression under the root will be negative. Therefore we say that the quadratic will have no root in normal circumstances, but there will be root. The root will be complex. All right, be complex number. So we have, in this case, how would the curve be? The curve will not touch the x-axis at all, because it is the values for x on the x-axis that will give us the root, right? But if the curve does not touch the x-axis, it means that we are not going to have a real root. So these roots are complex, yeah? Yes. So we have, they are complex. So we have, it can be this way. Here, when a is greater than 0, and it can as well be this way. It will not touch. So here, when a is less than 0, yeah. So these are the two situations when we have complex root of a quadratic expression. All right. So we are going to take example right now for these examples. Okay, let's take examples. These questions, they state that the instruction says that we should state whether these quadratic equations have equal roots or distinct roots or no roots. No root means on normal circumstances, if a quadratic has complex root at this stage, we say it has no root. But actually we are going to say it has complex root. Okay? Now, because it's not complex system, this is another actually branch of algebra actually, which we will do later on. Complex numbers. Okay? Very interesting area. Now, so we are going to state them. So we are going to use determinant. That's the expression, which is b squared minus 4ac. Okay? That's it. If this expression is equal to 0, it means that the equation, the quadratic function, has two roots that are the same. That is equal roots. Okay? And they are real. All right, let's see. Our a here is what? Our a here is what? Remember, if you see a standard quadratic equation, you want to know where the standard quadratic equation is. So that is ax squared plus bx plus c equals 0. Our a here is this one of b. So here our a is going to be 1, our b is what? 3, and our c is 3 also. Right? So we say our b is 3. So 3 squared minus 4 into a is what? 1, and c is 3. Okay? So let's solve this one. 3 squared is 9, minus 4 times 1 is 4, times 3 is 12. So this gives us minus 3. It is negative 3, right? So if it is negative 3, it means that this, we said that when b squared minus 4ac is less than 0, we are going to have complex root. Okay, so this one, we state that the expression or the equation has no root at your level, because according to the book, they say the instruction states you should state whether the quadratic equation has two equal roots or two distinct roots or no root. Here they are taking the complex root to be no root anyway. So to be specific, so your school, your examination board, whatever they say, you follow the instructions, okay? All right, for this one, they say we should state if the determinant is less than 0, we should say that it is no root, okay? But actually there should be a root, which is the complex one. All right, so that's it. Let's determine this one quickly. So here our A is what? What is in front here is 1. So our B is 2, our C is minus 11. That's negative 11. So our B, which is 2 squared, minus 4 into A, and times 11. 2 squared is 4, minus 4 times, minus is plus, 4 times 11 is 44. This gives us 48. It is greater than 0. So this one has to do with complex roots. And if this equals b squared minus 4ac, oh, you cannot see here. Sorry for that. I think, let me come here. Yes. All right. So, yeah. So if we have a situation where we have b squared minus 4ac, if this one is less than 0, we say we have complex root, okay, or no root according to the examination board. If this b squared minus 4ac is greater than 0, we have two distinct roots, okay? Then if this b squared minus 4ac is equal to 0, we have two equal roots. All right, two equal roots. So now that is it. So we have stated. Let's come here. So this one is greater than 0. So therefore, two distinct roots. So you can state it. Say this quadratic equation has two distinct roots. Okay, you can state that this quadratic equation that is here, it has two distinct roots. Yeah, good. Now let's come here. Here our A is 1. I think I need to, yeah, all right, good. Here our A is 1, our B is 2, our C is 1. So we have B squared is 2 squared minus 4A is 1, C is 1. All right, so 2 squared is what? 4 minus 4 times 1 times 1 is 4. So this equals 0. So therefore has two equal roots. This quadratic equation has two equal roots. Yes, according to our discriminant. All right. Now let's come here at number 5. Number 5, our A here is what? Is 5. Our B here is minus 3. Our C is 9. So our we say minus 3 all squared minus 4A, C is 5, C is 9. So minus 3 squared is 9, minus 4 times 5 is 20 times 9. That is 1, what? You got it, 20 times 9, that is it. 9 times 2 is 18, 108, right? Is that so? Yes, so this will give you negative, right? Yes, this is negative. This is negative. So that is, if it is negative, is it 9? Yes. So this is 10171, right? Negative. This is negative 171, yeah? That is it. So it is negative, you say what? It is going to have, it is less than 0, so it's complex root. So this equation, no matter what you do, you're going to end up having complex number there. Let's have this one. Our A here is what? 1. Our B is what? Minus 3. Our C is 4. So we have minus 3 all squared minus what? 4. A is 1, C is 4. So this is 3, 9 minus. Yes. 4 times 4 is 16, so minus 16. This is 7, which is negative 7. So this quadratic equation is also having complex roots, okay? It will have complex roots. Let's come to the last one for today. So our A here is negative 2, our B is 4, our C is negative 2. So B is 4 all squared minus 4, A is negative 2, or C is also negative 2. Yeah, so 4 is 16, 4 squared is 16. Positive times times negative is negative. 4 times 2 is 8 times 2 is 16. This is 0. So this will have two equal roots. This will have two equal roots. So thank you so much. Please, and we'll have a mathematics and algebra marathon, okay? And please, if you have any problem, any topic you want me to specially treat with you, with that maximum attention, with that in-depth explanation of the concepts, right? In any topic so far, as far as mathematics is concerned, at you can link me up, okay? We will work. Thank you so much. May God bless you. Please like, comment, and share my videos. I am your just a ordinary just teacher, all right? A teacher, trained and qualified and certified. Yeah. Thank you. Bye bye.